Now let's ask the question, how many liters of a 20% acid solution and how many liters of a 61% acid solution should be mixed together to make 80 liters of a 45% acid solution? Now, how's this different from the previous question? The previous question, by the way, was how many liters of a 20% acid solution should be mixed with 80 liters of a 61% acid solution to make a 45% acid solution. Notice that both questions talk about a 20% acid solution and a 61% acid solution mixing together to create a 45% acid solution. Both questions also have 80 liters appear somewhere. Here's the difference. In the previous question, that's the one that's most recently been said here, 80 liters was the amount solution for cup 2. Notice here in the wording was should be mixed with 80 liters of a 61% acid solution. So 80 liters was how much of the 61% acid solution. You'll notice though in the new question, that's the one at the top, 80 liters is the amount solution for the final bucket. Look at how it's phrased here. Da 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 should be mixed together to make 80 liters of a 45% acid solution. So here's the new question up at the top. And this is the picture of what we have so far. Again, there's a cup 1, a cup 2, and a bucket. There are 3 containers, and all of the numbers that have been provided have been placed into the appropriate place for every single container. You have to keep track of 3 things: the amount solution, the concentration, and the amount acid. And then we just place the things where we have them. Notice 80 is written down here. It's the amount of solution for the bucket. In the previous question, 80 was up here. It was the amount of solution in cup 2. Now what? Well, the amount of solution in cup 1 is unknown. The amount of solution in cup 2 is unknown. You notice the question marks up there. And here's the thing. If we don't know the amount of solution for cup 1, and we don't know the amount of solution for cup 2, can we write the same variable in both places of our diagram? What would this mean if we did that? Can we put an x here, where this question mark is, and an x here? If we did that, we would be assuming that the amount of solution of cup 1 and the amount of solution of cup 2 would be exactly the same. We would be saying that both cups are filled to the same beaker line. But that would be an assumption that we'd be making that's beyond what the problem would let us. Should we just assume that it's half-half? That's actually the same thing if we said it was 40 here and 40 there, because 40 plus 40 equals 80. We shouldn't do anything like that. Instead, let's create a variable x to represent the amount of solution in cup 1, and then recall that the amount of solution in cup 1 added to the amount of solution in cup 2 should be the amount in the bucket. So x plus something ought to equal 80. Well, we could fill that with a y, and then later say x plus y equals 80, or some would prefer to not create a variable called y and just replace the y with 80 minus x instead. So your call which way you'll do it. We're going to go with the y in place right now. Now let's apply the formula though, right? So 3 containers, the formula that says amount solution times concentration equals amount acid has to be used on each container. So you got to use that formula 3 times or you never get through these mixture problems. So here we go. This times that is right there, 0.20x, and then this times that listed right there, 0.61y, and then this times that listed right there. That's just 80 times 0.45. No point throwing that in a calculator or anything like that. And then finally, the amount of acid from cup 1 added to the amount of acid from cup 2. That should be the amount of acid in the bucket. So 0.20x plus 0.61y. Okay, here's the thing. We have the amount of acid for the bucket written in 2 different looking ways. Okay, there's a product, there's 80 times 0.45, and then there's a sum. There's 0.20x plus 0.61y. You're always going to have this happen. One time you get the bucket's amount of acid as a product because it's applying the formula amount solution times concentration. The other time you get the amount of acid as a sum because you're adding the amount of acid contributed from cup 1 to the amount of acid contributed from cup 2. So you always actually have 2 different looking formats. It has to be. One's a times, one's a plus, and they'll always look different, but they actually refer to the same thing, just how much acid, how many liters of acid are in the bucket. So we'll set them equal. And besides that, we also should recall that x plus y equals 80, or if you don't have a variable y, you should have an x here and an 80 minus x. But if you keep the variable y here, then you have x plus y equals 80. So here's the point. We have these 2 equations, and let's stick those at the top of the next slide. Take the easier equation, solve for one of the variables. I just went ahead and solved for y. So y equals 80 minus x. Make the replacement of 80 minus x for the y that appeared in the other equation. And now you have an equation that's all in x. So distribute the 0.61. You'll notice that the left side has 3 terms, 2 of which have x. Let's take the one term that doesn't have x and subtract that on both sides. Now every term with x is on the left side, every term without x is on the right side. Factor out the variable, divide both sides by 0.20 minus 0.61. And now we have x all by itself. Y, by the way, was 80 minus x, so this should be 80 minus that very large fraction. And the question, actually, if you go back, was how many liters of the 20% acid solution and how many liters of the 61% acid solution? So it sounded like one question, but it was asking for 2 things. And so here's how we'll write them. We need that fraction, liters of the 20% acid solution, and we need 80 minus that fraction, liters of the 61% acid solution.